this is x squared. Right side is y squared, but you should think of it as it's moved over. So it's a negative y squared. When we say same sign or opposite sign is if they are on the same side of the equation. So you move to one side, plus and minus means you are looking at a hyperbola equation. So we want to sketch out the hyperbola by writing out in standard form for the equation first. We want to complete the square. When you do standard form, you want to complete the square for both. So on the left, to complete the square, I need to expand first. I move the y term also across, and constant negative 12, I leave it on the right side. Okay, we go for completing the square here. This constant negative 16 that's created, we move across to the right. So we get a 4. 16 minus 12, we get 4. And you generally want to force the right-hand side to be 1. So you divide by 4 throughout the equation. I write it in standard form immediately. You want to write as a 2 squared. The 4 we write as a 2 squared. And the subsequent equation, let me write as 1 squared. Okay, so this is your hyperbola. First thing to do before you sketch it is you get asymptotes. Hyperbola will have 2 asymptotes. We have to find that first. And we recall the concept. Okay, you want to remove the squares, you want to remove the 1. So I get the squares removed. You get a plus and minus. Let's put it on the side with x. We make y the subject. I want to write it explicitly into 2 equations. Okay, we draw in the graph together. So help me set up the axis. Most of it is on the top left quadrant. Just allocate a little bit more space there. Like I said, I would not use a GC, but if you are very, very familiar, you can go ahead with the Conics function. Okay, but not a mass, and I won't do it. What are the things to take care of when you sketch? The steps will be, you mark out the following. Mark out the center of the hyperbola first. Center is at negative 4, 2. You check your numerators to be 0, it gives you the center. And also the y-intercept of your asymptotes. Y-intercept of asymptote is at 4 and 0. So can we mark out these two? Let's go for center first. Center at negative 4, 2. This is the center. Okay, just mark out as a coordinate straight away. Center we need to mark out. It's going to cut the y-intercept at 0 for one asymptote. The other asymptote cuts at 4. We mark both out. And the reason for that is because asymptotes will pass through the center and also its own y-intercept. So it will look like this, and then I extend. This is how the asymptote will look like. Must pass through the center and its y-intercept. Okay, dotted line for the asymptote. So same for the second asymptote. It will look like this. Label in your asymptotes first. We get the graph drawn, the distance to the vertex. Oh no, we should do more things first. Get the orientation first, number 2. What is the orientation? You see that the graph is a positive x squared. Positive x squared means the graph will take on this shape, and this is the center. And number 3, you want to check that distance from vertex to center. What's the distance from vertex to center for our case? It is this distance that we are looking at. So this distance, we read off the value below your x. It's 2 units. Okay, so I will go to the graph. We mark out 2 units to the right and to the left. We get -6 and -2. Okay, 2 units. So we mark out also the vertex position. Okay, this is a key feature which you need to label in as a coordinate as well. So this is -2, 2 and -6, 2. Since it's a horizontal hyperbola, we will now start to draw and turn at this point towards the left and right. Just make sure that your endpoints are close to your asymptote. Okay, they only want the key features, which are the center and the 2 vertices. And they also tell you don't need to give coordinate of the intercepts. Intercepts, if you want to find the coordinate, no choice, you have to put x is 0 or y is 0.